to address the quadratic formula. And the quadratic formula is written in the form ax squared plus bx plus c is equal to 0. The quadratic formula is also one way of solving a quadratic equation, just as factoring is, which we have done up until this point. Quadratic formula, like I said, and we will talk about that in section 7.2, but this section is completing the square. And completing the square is basically using the concept, like in example 1, that if you have a perfect square on one side of the equation, then by square rooting both sides, you can solve for the two roots or two solutions for x. So in part 1, it's very simple to, first of all, recognize that if you have a grouping, whether it is just simply x squared or a whole grouping that is to the second power, that you could just simply square root both sides. The square root and the squared are going to cancel out. And then to finish solving for x, we would subtract 3 to both sides. And so we'd have x is equal to a negative 3 plus or minus the square root of 5. In example 3, very similar to example number 2, if you have a grouping that is a perfect squared, you can square root both sides so that the square root and the squared will cancel out. We are going to be working with imaginary numbers, so this would be plus or minus 2i square roots of 2. And then subtracting the 2 over, that would go in front of the radical. And if you have an I, remember that it is written in the a plus or minus bi form. On example number 5, as long as one side of the equation is a perfect square root, this 4 is a perfect square root, I could go ahead and square root both sides. The other thing you could do is multiply that 4 over so that you just have x minus 5 quantity squared is equal to 196. Square root both sides. So we'd have x minus 5 is equal to plus or minus the square root of 196 is 14. So this one comes out evenly. If I add that 5 over, if you have gotten rid of the radical has taken care of itself. Don't leave it in this form. Please go through and take 5 plus 14, which is 19, and 5 minus 14, which is a negative 9. Because there are times when you are going to come up with integers for your answers or non-radicals, and you want this in the simplest form possible. Last example on part 1, if you go through and square root both sides, you would have 1/3 x minus 7 is equal to plus or minus 2 square roots of 3. Solving for x, I'd end up with 1/3 x is equal to 7 plus or minus 2 square roots of 3. And then to finish out, I'd have to take both sides times 3. So this would be 21 plus or minus 6 square roots of 3. Okay. Now, that is part 1. Part 2, which is also section 7.1, now takes it a step further. What happens if you don't have a perfect squared, just like up above here? We had a perfect square all set up. In the first part of the assignment, perfect squared is all set up. Well, what happens if you don't? Then this is where completing the square comes into play. So these are the steps that you would have to do first of all. First of all, with completing the square, your a, because this is in the ax squared plus bx plus c is equal to 0 form, your a has to be 1, okay? So if I, first of all, want to make sure there's no coefficient on x squared. Then, as long as I have that, then the first thing I'm going to do is add this c over. So I have x squared minus 4x is equal to 6. Now this left-hand side is going to be our perfect squared. This is going to be our quantity squared. Just like up here on number 2, we had this quantity squared. That's what we're going to do down here with this minus 4x. So how do we come up with what is in this perfect squared? Okay, what we do is first of all take our variable, take our sign. What goes in here is half of b. So we take 4 divided by 2, which goes in here. But then we square this because what we're really doing is adding 4 to both sides of the equation, because x squared minus 4x plus 4 factors to x minus 2 times x minus 2. So in order to get this to be a perfect squared, we have to add 4 to both sides. And now we have this as a perfect squared. And now, once we have this as a perfect squared, we can take the steps that we did up above. So x minus 2 is equal to plus or minus the square root of 10. So x is equal to 2 plus or minus the square root of 10. Now what works pretty good is if your b is even, when you divide by 2, this number is going to be an integer. On example number 7, it shows, well, what happens if it's odd? Then you're going to start working with some fractions. So the very first thing I do is, first of all, make sure that my a is positive, a positive 1. If it is, then I take the same steps that we took in problem 6. We subtract the 3 over. I'm going to come down here and do my parentheses. I'm going to leave this blank here so I know that I've got to add something. Match up the a, match up the sign. I'm going to take 5 divided by 2, which goes in here. So what I'm going to be adding to both sides is 5/2 squared, or 25/4. So negative 3 plus 25/4, this is negative 12/4 plus 25/4. I need to get a common denominator to put those in, so I have 13/4. And now I can go, I have a perfect squared on the left-hand side, so I can square root both sides. So I have a minus 5/2 is equal to plus or minus the square root of 13. Square root of 4 is 2. And then by adding that 5/2 over, I end up with 5/2 plus or minus the square root of 13 over 2. Make sure that you never leave a radical in the denominator. So if this had not become a perfect square, I would have had to rationalize that. Now on example number 8, this is an example of what happens if your a is not 1. All you're going to do is just go through and divide to get rid of that. So I have y squared plus y plus 5/2 is equal to 0. And then the steps stay the same. Subtract the 5/2, so I have y squared plus y is equal to a negative 5/2. Leave a blank here. I match up a variable, match up the sign. I have to take half of b, and then I square it to see what I'm adding to both sides. So this would factor to y plus 1/2 times y plus 1/2. Common denominator would be 4, so a negative 10/4 plus 1/4 would be a negative 9/4. Square root both sides, so I have y plus 1/2 is equal to plus or minus 3i over 2. So y is going to be equal to a negative 1/2 plus or minus 3i over 2. Last example. If you want to hit pause and work through this, see if you can come up with the right answer, please do. My a is not 1, so multiply to get that to be 1, so x squared minus 4x. The c is already over on the right-hand side, so I can go through. Remember, half of 4 is 2, square it, so that the x squared minus 4x plus 4 does factor to x minus 2 times x minus 2. That's what we want. Make sure to add that 4 to the right-hand side as well. Square root both sides, so I have x minus 2 is equal to plus or minus the square root of 10. So x is equal to 2 plus or minus the square root of 10.